This video is about the Bohr model. Before going into the details of the Bohr model, let's return to an earlier model of the atom that we learned about in subtopic 7.3. This was the Rutherford model. The basic assumptions of this model are that almost all of the atom's mass is contained in a very small, dense volume that we now call the nucleus, that all the positive charge is contained in the nucleus, and that negatively charged electrons orbit the nucleus in circular orbit. A major problem with this model is that when electrons move in a circular orbit, they accelerate. Based on classical physics concepts, this would mean that the electrons would emit electromagnetic radiation, lose energy, and eventually spiral into the nucleus. Since this clearly does not happen in real life, if it would, atoms would not exist, therefore the Rutherford model had to be improved. This is exactly what the Bohr model does. It maintains the assumption that electrons orbit the nucleus. However, it states that these orbits are fixed or quantized. These orbits are basically the same as electron energy levels in an atom that we learned about in subtopic 7.1. Electrons cannot move from one orbit or energy level to another gradually, but they must absorb or emit a specific amount or quantum of energy all at once in form of a photon. A third key concept in the Bohr model is that angular momentum in these orbits is quantized. The formula in the IB Physics data booklet that can be used to calculate the angular momentum in different orbits looks like this. Here are the variables that are present in this formula. mvr on the left-hand side of the equation is defined as angular momentum. The second equation related to the Bohr model is this. Here are the related variables. Note that EV in this equation just means that the energy value is in electron volts. Also, you might have noticed that the energy here is negative. This is because the electron is bound to the nucleus, and in order to move the electron from a lower to a higher orbit or energy state, energy must be supplied to the atom. Finally, let's just add that this model also has shortcomings, for example, that it only works for simple, hydrogen-like atoms. When extended to more complicated atoms, the model fails. This wraps up our discussion of the Bohr model. In the next video, we'll learn about the wave function, which will help us understand how the Bohr model was improved.